Hello, everybody. How are you doing? I hope well. And I would like to start with the questions, me too. I would like to know how many of you are thinking of using microservices in their production systems. Quite a lot. And I think you're quite foolish because you don't know what you're getting into. Because it's lots and lots of work. And today I will try to talk about our journey as a company. I work for Euclidea, which is a company that provides financial services for the end user. Basically, we allow people to invest their savings into one of our financial portfolios, where each financial portfolio is composed of many different financial instruments. So today I will start with a story of a production error. Basically, our user checks their personal dashboards to track how the investment is going. And so one day, our users couldn't check and see their private dashboards. So my boss said to me, Giuseppe, we got a problem, but without keeping a very British aplomb, was quite a bit upset. And to be honest, it was kind of a tense situation because the users check their dashboards just like at the start of the day, like they want to know if the investments are going well or not. And so it was not like dismantling a bomb on a bus, but close. Because to fix this kind of problem, I had to access the production database and delete some rows, do some updates, and do some inserts. How many of you have done any kind of such things in a production database? So you know the feeling. It's not nice, it's not a good idea, and I totally discourage you to do it. But to understand what the problem was about, I need to get a bit more into the details. So this is a very silly example about the asset allocation. Basically, there are multiple dashboards where the user can check the progress of their investment. And let's say that each financial instrument is classified into subcategories. So it's classified into asset class and sub-asset class. So for example, you have a financial instrument which is part of a bond, and then the next categorization is like short-term bond, and then you got the financial instruments. Just imagine here that these categories are like drop-downs. So the nature of data is kind of very hierarchical. Now, to get to the gist of the problem, I have to talk about a bit about how our team was structured. So we got team finance, which takes care of everything related to the financial world, and the IT team, which takes care of all the production web applications. So there was a syncing process going from the financial team to the production database for the web application. And so we could categorize the kind of traffic and the kind of pattern of data usage between the two different databases in one that was with lots of read and write operations, and the other one mostly read operations, because the web app just displays the data, doesn't do anything with the data, while the finance team does lots of many things with the data, makes lots of analysis with the time series kind of data, all of this sort of stuff. So there was a syncing process going on, and the problem was related to missing data, as simple as that. So the kind of tables in both databases when it comes to the financial instruments were kind of similar. So we got tables related to taxonomies and other ones related to performance tracking. And the databases, as I told you before, were handled by different teams. So the syncing process was also kind of manual. What was happening is that during the months, sometimes our financial teams decides to update the core portfolios. So this means that some instruments get in, some get out, according to their goals, their objectives. And so at the beginning, we didn't thought about a process of sync. And so we relied on, oh, okay, I added these instruments. We need to replicate this kind of data on the other database. And although the UI showed the kind of a hierarchical structure, the data was mostly stored as flat. And we will see why this is not like such a good idea. So what can go wrong about this? So we talked about the syncing process that was pretty much manual and wasn't a good idea, of course, because it's prone to error, you got missing data. We can have all the kind of problems. So of course, it's not a good idea. The data structure is kind of hierarchical, and we were storing in a flat way in the database. So this means that if you have a production application that gets a lot of traffic, you have lots of workloads related to restructure and compose the hierarchical structure all the time. And so this is not really good for a scaling perspective. So what is the solution we adopted? The solution we adopted is, if you have a problem with two databases, let's add another one, so maybe you can solve. So we got the syncing process, so we got this read-write database, and then we got what we called a border database. This database contains the read model. So basically, we divided the two databases according to their pattern of usage. So we got here the update model, write update model, and here we got the read model. You see also the bounding box. This means that the team finance took ownership of the read data. And this is very important. So the web app could only rely on the border database. In this way, we don't care about what's happening in investment database. We only care about the read model. Another advantage is that we can have different scaling structures because they have different needs, both database. So what we realized in the end was we were just applying common query responsibility segregation principle, where basically we had different models. We had two different databases because we had two different needs. So this was kind of a trigger to go deeper and understand how you can create a web application which is more reliable, a web application that can get more tasks, and basically we got down into understanding how we could improve our web applications in general. So about me, I'm a software developer like you. I'm kind of interested in cloud computing, and you can reach me here if you want to share ideas about distributed systems. And my company, I talked to you about before, and it provides this service of like kind of managed service related to the investments. And it's the first company in Italy that published MiFID II compliant report on cost. So basically, this is a big deal. It is a big deal because what happens in the financial world is that you buy some financial instruments, you buy some financial services, and you don't really know the cost. You only got to know the cost only after 1 year. And with the MiFID II report, you have to split and declare exactly the cost of the financial instruments and the cost you're paying for the provider. So this is very a big deal, and we provided a report which looks like a utility bill, so you exactly know how much you're paying. So today the agenda is quite thick, and I'll go deep down into each topic. So what is serverless? Serverless is a way to avoid to manage infrastructure. It's a thing that speaks very well to developers because it really helps to take care of applications, but only by our perspective, which is writing some code without bothering about scaling infrastructure, securing infrastructure. We're very happy to offload these tasks to a cloud provider. So that's a very good idea. Another very important point of the serverless, because there were already other kind of paradigms that allow you to do that, is that you only pay for the kind of infrastructure that you are using. You don't pay if nobody is not using your web application. So that's a very good selling point for example, producing MVP, proof of concept for startups, where basically at the beginning they don't have much traffic, so it may be a good idea, and aligns the economic incentives with the progress of a company. So you only pay for what exactly you're using. So, as I said, serverless is a kind of an umbrella term for any technologies that cost you nothing if no one is using it. And of course, when you offload the task of taking care of the infrastructure to a cloud provider, this means that you are delegating the uptime to a third party. So that's very important. It's not something that you should not take care of. So the idea from the Amazon perspective is to provide a product where you only care to write business logic. And this is all fancy, and it's like, can be kind of a dream. It's very useful, but we are not sure that we are there yet. So basically, we don't know. Can we exactly just write business logic? It depends. That's the answer, because it really depends on the kind of the workloads you have, because there are lots of limitations. So one of the limitations is the limited lifetime. The function as a service usually run between, now is 15 minutes with AWS Lambda, and you got this problem of cold start, which is kind of a big issue if you have something that, some kind of applications that needs real time. So it's not a good idea to use a serverless technology for that. Another kind of limitations is the input-output bottlenecks, because the way serverless is thought out, the main use case is when the data is pushed towards the functions and not the other way around. Because whenever we want to access data, you have to go through network calls, and this is slower than, for example, accessing data on an SSD. It's clearly slower. So it's something that you need to take care of, think about at least, and there's no specialized hardware. So if you want to use, I don't know, some kind of GPUs, you want to do some kind of machine learning kind of tasks, you can really do it. Or you can do it in a limited fashion because you can't use any kind of specialized hardware. So it's a good idea for specific use case. For other things, you have to evaluate. And on this paper, serverless computing, one step forwards, two steps back, there are plenty of more details about the different use cases, when it's a good idea or not a good idea of using it. So this is an example of an application that converts text to speech. And if you ever have seen any kind of blog post on the AWS websites, you always see the icon where you can listen to a post. And I think this is the application that's behind it. So you got the static content that is served by S3. And then let's look at this flow below. So you got an endpoint which allows you to post new text. And then what happens? This Lambda function stores the text in the DynamoDB database. And here you got all the production part. So the post gets stored. This is in auto-scaling. You don't need to care about infrastructure. And then later happens the consumption of the data. So there's an SNS notification which triggers another Lambda functions, which then interacts with Poly, which is basically the service that translates the text to the audio file format. And then the Lambda function stores the status of the transformation in DynamoDB and the link of the object that is stored in the S3 bucket. Then you got another endpoint upward. This is less interesting, but basically what you have is that you allow user to refresh to get the stored, stored speech that you basically already translated from Amazon Poly. So SNS here is an example of decoupling. So here you got the production part, here you got the consumption part. And it's interesting because if you see the application, it's literally a toy. It's very simple. All that the Lambda functions do is basically glue different services together. And this is very important because one of the main themes about serverless kind of architecture is that you use as many services as possible. And this goes by the name of serviceful serverless. So you only care about orchestrating and putting together these services, and you write very little code because code is a liability and it's hard to maintain. You need to do lots of investments. And this might be a good idea for, I don't know, a text-to-speech application. So we go to this nice, interesting monolith definition. So basically, a monolith is something that compacts many different domains in the same application. And this might be a good idea or a bad idea according to what you're doing. And definitely we can say that everybody starts with a monolith. And it's a very good idea because it allows you to see the whole domain of your business. So you see the many different domains that your company is doing, because there are many different aspects of running a business. And then they got your microservice, which basically is like the smallest autonomous boundary related to a service. So who uses microservices? Microservices are very well adopted by big companies, and I think for a specific reasons, for a couple of reasons at least. First, they need the very different scaling needs according to their applications. So according to the kind of services you're doing, you may have different scalability needs. Another point of advantage is the resilience. So if your application is distributed and some services is not working correctly, the application is still up. So for example, you want your services to be highly available and highly resilient on Black Friday if you're in commerce. And so adopting microservices is a good idea. Another point is that these companies have lots and lots of developers. So when you need to coordinate multiple teams, it starts to become really hard. So you want to make small teams that are as autonomous as possible, so everybody can do its kind of dance. So if you pretend that they're all listening to different kind of music, so everybody's doing his own dance, they're just slightly aware of the environment, of course, not to interfere with each other. So I think this is one of the reasons, fundamental reasons for these companies to adopt microservices. So if you're a small company and you have, I don't know, 4 or 5 developers, adopting microservices might not be a good idea unless you're willing to invest lots of time in upgrading the skills of your team. So, should you use microservices? It depends, again. My advice is, since we are moving to a world of distributed systems where we pretty much leverage the cloud offering of different providers, I think you should definitely invest some money. So we talk a bit about the pros and cons. So you definitely have, as the pros, scalability. You can change the technology stack. You also got reusability. For example, in our company, we created a different microservice for the digital signature process. This allows us to basically sign a document unrelated to the different contexts. Before, this was a thing that was immersed in a very specific flow. But you also got increased effort in monitoring operations. You could definitely have higher complexity and requires serious expertise. I don't want to scare you, but it means we got a lot to learn. And it's fun. So distributed systems are definitely everywhere. If you're doing any kind of web application, you're definitely using some kind of services. So you better get ready and start learning about the skill set you need in order to run them, regardless if you're using or not a microservices architecture. So Now I'm going to show you a very secret recipe about how you extract some service from a monolith. So keep that in mind. This is super secret. So here we can see the different monoliths that my company Euclidea has. So here we got the financial team that does portfolio analytics and all of that kind of stuff. And here we got the different aspects of the web applications. So we got the onboarding process, the digital signature, the company that provides the service to acquire, to sell and buy financial instruments. We got the back office and the private areas that the users see after they sign the contract and start investing their money. So in order to extract a service, you have to think about many different aspects. First of all, if it's a stateful or a stateless service. So if it's a stateless service, it means that you don't store data into a database. For example, the digital signature process requires a user ID, a one-time password, and a representation of the document that needs to be signed. And it returns the signed document. And it doesn't store any kind of data into the database. So these are the kind of services that are very easy to extract and are a good idea to start from here, because then you acquire more skills in the process. If you got a different kind of service, like more of a stateful kind of service, it's a bit more complicated, because if you have a very normalized database, it becomes really hard sometimes to decide where to cut, for example, the relations among different data tables. So in general, the idea is to provide some kind of API on a set of business logic. So in Django, there's the idea of providing this services layer, and this allows you to separate the web application from the business logic. And so it's a good idea to start there. So you define the API, and then you make all code depending on this API. Then slowly, you create another database that contains the table of interest for this service. And of course, after you have done it, you can start switching the data store from D1 to D2, and you also need to consider the data migration, because this is very easy if you don't have any data, but if you have lots of data, this is not a very easy task to do. After this, you can extract the API and expose it through a REST or an event interface. Now, if you apply this recipe to everything, and basically you create lots of different services with a REST interface, what you're doing is basically you're leaving off all the advantages that gives you a monolith, and you're just taking all the disadvantages of the distributed systems, because you create lots of dependencies around. And if you just use the synchronous kind of communication, it becomes what is called a distributed monolith. So basically, you replace method calls for API calls. And this is not a very intelligent idea. So you really need to think if you want to use a synchronous kind of communication or an asynchronous kind of communication. Synchronous communications might be really good for API that interacts with UIs. Asynchronous kind of services are very useful for all the processes that happen downstreams. So for example, in our case, we got the digital signature that is a stateless service, happens online, have to be available, have to happen at this specific moment because the user receives a one-time password. So it makes sense to be synchronous. But for example, for the order management service, which happens later when the user has signed the contract, has complete sense to happen asynchronously. So we decided to use a queue we put some tasks, some jobs into it, and then asynchronously, we start creating all the information that are needed to interact with financial services. So this is the recipe, but we shouldn't forget about the spices. We talk a bit about the data, how the coupling is very important in limiting us to free ourselves from separating the different services. And the general idea is that each microservice should have its own data store. This is because you want to make them very independent. So what happens is that if you have different microservices that have some kind of data in commons, you have to think about if you want to put all the tables together, or you want to separate some data, or you want to have some kind of duplication of data. The data duplication is kind of very useful because, again, allows you to be autonomous. But as you duplicate some data to make some service independent, you have to think about having only a single source that is authoritative for that kind of data. And of course, the main course. The main course is what I think one of the most important is how you integrate the different microservices. So we talked before about the synchronous or asynchronous kind of interaction, but there are so many patterns that you can use. Also, another important aspects, if you have some kind of event services, if you can use messages that can be consumed. So if a message is consumed, it means that nobody can see it. If a message is observed, many services can see it and can act on it. So in general, when you want to make a system that is very easy to evolve, you want to move towards an event kind of architecture. So where basically when some interesting events happen, you have a notification and multiple services can act on it. And they don't need to know about each other. And this is very useful. Among the different patterns that you can have, we got the request reply. This is one, the kind you already know. Then the request reaction is kind of an advanced version of request reply. So when you got the request reply, both services have to be available at the same time. And so you also got a temporal kind of coupling. With the request reaction, you got one service that talks to another, and the service returns back kind of a ticket, like, okay, you want this job to be done, I'll take care of it, I'll release to you an ID. And then the other service goes on doing that task, and then it notifies the completion of a task to the service that's asked for it. Then another idea is to use the inversion of communication. So instead of having a service that talks to another, you can have, as we said before, an event system. So basically, there are some events, and you react to it. Other patterns are related to how you manage distributed transactions. One of those patterns is Saga. So basically, you got many services which do parts of a transaction into a database or any kind of data stores. And you also have some kind of workflow engine that manages the state across the many different system sub-services. And if something happens, there are some kind of compensation action if the transaction is not successful across the whole services. So you have many different services. Each service does part of the job, and each job stores the completion of a task into a data store. If something goes wrong, you have to make sure that the state is consistent across the different services. So you have to have each services to implement some kind of compensation action. As you move towards this kind of problem, it becomes more and more complex to do it correctly. And this is very important. When you move to a distributed kind of system, you need to think about all the kind of failures that can happen and all kind of compensation actions that you should carry on For example, in our case, if a user is not able to sign the document of the contract, we have a different flow for it. Basically, we send a notification back to the user like, we appreciate your interest and we want you to finish our onboarding process through an email. And so basically, he got a link where he can sign the document. Or later, if he logs in again in the web application, he can see that he needs to do this other step of signing the contract. And it's taken care of all automatically. And basically, it's kind of a compensation action if something is not working correctly. So you need to think about fallbacks, compensation mechanism, and also idempotent behavior for consumer service. So when you got some services that can go up or down for any kind of reasons, or if you're using a queue kind of service, you may have consumer services of the events that basically can take lots of duplicated kind of requests. So you need to implement an idempotent kind of behavior. This means that even though a service gets lots of post requests, since we're able to understand if we got some duplicate requests, or if we understand that an action has always the same kind of response, so we can move on. So another issue when it comes to microservices, especially if you have lots of them, like in the scale of, I don't know, 100, 200, like even 50, but I would say even over 10, 15, 20, whatever, you need to have some kind of consumer contracts. This is basically a way to codify the interaction between different services. So for example, you may codify how the service interacts, so what kind of data is sent, what kind of a response is expected, and there are different frameworks for that. And for example, one that is very recent is called Pact, and allows basically to codify this kind of aspects. So also, after having all kind of integration tests, end-to-end tests, you also should have some kind of test that basically check that you're still, for some API, providing some kind of services, and you're still interacting with them correctly. This is very important. Otherwise, if you just use REST and JSON and you don't have any kind of schema, how can you be sure that if you have done some changes to an API, all the services behave correctly? You will never know. And that will cost much more to understand or to solve even any kind of problems like that. So my general advice, if you want to move towards a microservice kind of architecture, is to migrate in small, safe steps. So you should really understand, think about how you want to split the data, how you want to integrate the different services, what kind of communication you may want to have, what kind of compensation action you want to have if something doesn't go well. You need to take care about all of these different aspects. Because saying that you're doing microservices is cool, but then solving the problems is not easy if you're not prepared for it. So if you migrate slowly, you basically learn the knowledge. As you progress forward, it becomes easier. We will see later that another requirement of applying microservices correctly is to have lots of tools which helps with observability and tracing the different requests among different services. Basically, if you have a microservice kind of architecture, you may want to trace from the user requests whatever happens to all the different subsystems. Otherwise, like with some kind of correlation IDs, otherwise you might not know what happens if there is some problems and where is the problem. So you may actually combine and trace the logging information with this kind of tools. Testing and monitoring. This is another important aspect. I think you all know about this. And so we'll talk more about the other aspects. We kind of made some points to it. So as I mentioned before, you may want to use some kind of testing the contracts between the different kind of APIs. And another important aspect that it's very well known in the serverless world is that when you use some kind of distributed architecture, testing becomes much harder, because how can you test locally when you have so many services? How can you do that? Like, it's very hard. Or for example, in production systems, you may have lots and lots of data. So how can you test for that? It becomes really hard. So I know this sounds scary, but that doesn't mean that when you make a change, you push and it goes in production like that. No, basically, the usual approach is to split the traffic. So for example, you got 90% of the traffic that goes to the old system, and 10% of the traffic which goes to the new system. In this way, you understand if something goes wrong. You may experience how the users are behaving, if the system are working correctly. And as you see, as you gain more confidence, you increase this kind of split traffic until you basically offload the old system of any kind of request. Other important things, we talked about this before, log aggregation and the ability to trace a user request over different subsystems. You have to have lots of metrics to trace how the system is doing, like the production systems, also the application, all kind of metrics related to the applications. So for example, anything related to how many signatures you have provided. If there is a very low number of signatures, should this trigger an alarm? And so also investing in tooling is very, very important, because otherwise you're just like completely blind. So all of this is just to give an idea of what it means, all the different kinds of problems and opportunities you may have to use microservices. My idea is that we're moving towards a world where basically we're using many distributed systems, we make use of many different services to provide value to our customers. So my idea is that we need to learn about this more and more. It's becoming more important because, for example, in the text-to-speech example, you don't want to implement speech synthesizers. You may use just Poly, but to use these services, you need to learn how you glue them together, and you really need to learn also how they should interact, how you can use them. So you should start investing time into this. So I started with a 500 error, internal server error, and I will conclude with the 500 times thanks. If there are any questions.
Thank you, Giuseppe. I think we have time for one question. Anybody? Okay. Thank you so much, Giuseppe. Big round of applause for him. Yes.